Hi guys. So the first thing I want you to do is complete the warm-up. So take about 5 minutes to do that and make sure you complete it right on your warm-up sheet. So while you're doing that, pause the video and then when you're ready, hit play again and we'll continue on with the notes for today. All right, so let's talk about the warm-up. Hopefully you've already turned in your warm-up sheets. If you haven't turned in your warm-up sheets, make sure you do that right now before you look at the answers for this. So after turning in your warm-up sheets, looking at the first warm-up problem, you were supposed to have an angle ABD, so using the diagram that was already up on the board. Angle ABD is 89 degrees, ABC was 27. In order to find the measure of CBD, subtract using the angle subtraction postulate. So if you have a whole angle minus the part, it's going to equal the other part, so you get 62. And then I just use the same diagram to mark my expressions for number 2. So if you look at number 2, it's the green. So DBC is 3x plus 7, angle ABC, 5x minus 2, and then the entire angle is 61. So the relationship between those three expressions is the fact that the two parts added together equals the whole angle. So 3x plus 7 plus 5x minus 2 added together equals 61. And then you just solve it for x and you should get x equals 7. So the next thing I want to do is I want to go over one of the pages that you had for homework last night, which was page 40. So in your note packet, you can take out page 40. Don't worry about the other problems for right now that you had for homework. I'll check those tomorrow. So just focus on page 40 for right now. Now, some of you I know already have this started or completed from what we did in class, but really what I want to do is just go through it quickly with you. So angle subtraction postulate means that you're going to be starting with the whole angle and you're going to be subtracting off one of the parts and that'll leave you with the other part. That's what the angle subtraction postulate says. So if you start with the whole angle, you subtract off one of the parts, you're left with the other part. So in terms of this picture here, if I start with this whole angle here, angle ABD, and I subtract off one of these pieces, so let's say I subtract off this piece right here, which I'm going to call angle 1, I'm going to be left with the other part here, so this part right here, which I'll call angle 2. And I'm going to use congruent here just because I'm not putting the m's in front for measure, so I'm going to use congruent. I can also switch this and say, okay, well, what if I take that whole angle and this time I subtract off angle 2 as the part? Well, if I do that, then I'm left with angle 1. Keep in mind when I'm writing these, if you're using an entire angle, meaning an angle that has more than one part, so if you look angle ABD, you don't want to use a number to represent that. So like I don't want to put a 3 somewhere in here because then it's going to be confusing as to what does angle 3 really mean. Does it mean this part where I place the 3, or does it mean this part where I place the 3, or does it mean the whole thing? So your best bet for angles that have multiple parts in them is to use 3 letters. That's the easiest way for someone reading your paper to know exactly what you're talking about. So just keep that in mind, where you can put numbers in angles. When it's just one angle, one space, numbers are totally fine. And it's definitely the easier way to go about it. So let's look at the proof down here that you were supposed to complete. So kind of going along with the notation, let's first just make these a little bit easier so that when we go to write the proof, we don't have all of these letters to use. So we're given that angle JNL. So JNL is this whole angle. We're given that that is congruent to angle MNK. So that their measures are equal, they're congruent. So we're given the whole angles. And what I'm going to do is I'm going to cross off M, and I'm just going to make it congruent. So that shortens it up just a little tiny bit. And then what I'm going to do is I'm going to look at what I'm trying to prove. So I'm trying to prove that angle JNK, so JNK, which I'm going to call angle 1, I want to prove that this angle is congruent to angle MNL. So MNL, I'm going to call angle 2. So I'm trying to prove, so I'm just going to cross that off and say, I'm going to try to prove that angles 1 and 2 are congruent. So the first thing I want to do is I want to get my given down. So my given is going to be that angle JNL is congruent to angle MNK. And remember, you can't shorten these and put numbers in for those because those angles have multiple parts within them. So you have to use 3 letters to name those. So now, since I'm starting with the whole angle, I'm going to use angle subtraction to subtract off the piece that's the same in both angles. So the piece that's the same in both angles is this piece right here. So if you look at the green angle, it contains angle 1 plus what I call angle 3. And the red angle is going to contain angle 2 plus the same angle 3. So that means I'm going to have to state that angle 3 is the same in both of those, and that's going to be by the reflexive property because it's shared. Angle 3 is equal to itself. So now what I'm trying to show, remember, is that angle 1 is congruent to angle 2. So I'm taking the whole angle and I'm going to subtract off the congruent piece from each. So what I'm going to do is I'm going to take statements 1 and 2 and I'm going to subtract them. So I have angle JNL minus angle 3. So if I start with something that's congruent and I subtract the same thing off from both sides, it's still going to be congruent. So angle MNK minus angle 3 is congruent to JNL minus angle 3. That's the subtraction property of equality. So if you start with something that's equal, you subtract off the same thing from both sides, it's still going to be equal. Now what you want to do is you want to take these different pieces here and actually state, well, what are they equal to in terms of our picture? So if I take angle JNL, which is the green angle, and I subtract off angle 3, I'm going to be left with angle 1. And if I take this angle, MNK, which is the red angle, and I subtract off angle 3, I'm going to be left with angle 2. So MNK minus angle 3 is going to be congruent to angle 2, and this is the angle subtraction postulate, which is at the top of the page here. And then the last step, well, if you look, we have this right here matches this. So what I can do is I can replace this part in the rectangle with angle 1. And then this is the same thing as that right there. So I can replace what's in the oval with angle 2. And since I'm substituting that in, the reason for that is substitution. So then the next thing we're going to look at today is how do we use these mini proofs for the subtraction and addition postulates inside larger proofs. So let's go to the next page and look at an example of that. So for this first example, you're given several different things here. So the first thing, this given right here, you can just cross that off. That's not really relevant. That's just telling you that you have a line, A, B, C, D, which you can see just by looking at the picture. So I wouldn't worry about that. So go ahead and write your T, write your statements, reasons, and then you can put your givens down. Now when I write my givens, I'm going to group them so that they are grouped by similarity. So what that means is I'm going to write the perpendicular givens together, and then everything else I'm going to list separately because they're all different, the other givens. So I have 3 different givens. And so for my reasons, I'm going to write 1, 2, 3, and then one big given. So now what I'm going to focus on is using these givens because I need to prove triangle ABF, so this triangle right here, I need to prove that that triangle is congruent to DCE. So that's my end goal. And remember, to prove 2 triangles are congruent, we have 5 different ways we can do that. SSS, SAS, ASA, angle, angle, side, and HL. Those are the only methods that you can use to prove that these two triangles are congruent. So let's go ahead and mark what we have. So the first thing is we have FA is perpendicular to AD. So if those are perpendicular, that means I have a right angle there. And then same thing is going to go for this other side. So if ED is perpendicular to AD, that means I have a right angle at angle D. So that's going to be the first conclusion that I can make. So I can say angle A and angle D are right angles. And the reason for that is because perpendicular lines form right angles, or perpendicular lines imply right angles, something along those lines. So now you have to remember, whenever you have right angles, there's two things that you can say about them. You can say that they form right triangles. You can also say that they're equal to each other. So you kind of have to look ahead before you can make the decision as to which way you want to go about it. Because in order to say that you have right triangles, that's going to help you with HL, versus if you're trying to use one of the other methods with an A in it, so one of these, then you want to actually say that those angles are congruent. So if I look ahead, let's mark these other pieces that they give us. So they give us AF is congruent to DE. They also give us AC, so this whole thing is congruent to DB. So this whole thing here. So when I look at this right away, I know that I'm not going to be using HL. The reason for that is because I don't have a hypotenuse marked. And there's no way for me to be able to get that hypotenuse. The fact that I have this entire segment is congruent to this entire segment, even though they're not segments of the triangles or not sides of the triangles, I know right away that those are going to actually help me get AB and CD being congruent, because they're the larger sides, or I guess the AB and CD are the parts of those larger segments. So I can tell right away I'm not using HL, which tells me that I should actually say that these two angles are congruent, because that's going to help me get an A in one of these methods. So let's look at doing that. So the first thing will be A is congruent to angle D, and that's because all right angles are congruent. So now when you look at this, you have to ask yourself, well, which method am I going to be using? So when I look at this, I have a side, I have an angle, and I'm going to be able to prove that this side right here is congruent to this side right here. And the reason why I know that is because I see the whole segments, and I see the shared side right here, which is going to be the reflexive property. And if I take the whole segments and I subtract off BC from them, I'll be able to show that the two green segments are congruent. So that tells me I'll be able to use side, angle, side as my method. And right now, I've already stated in my proof a set of sides and a set of angles. So I have S and A, and I need to prove the other set of sides. So I need to prove that these sides here are congruent. So this is where it's tying into what we did yesterday and what we did at the beginning of class today. So this is where we use the segment subtraction postulate in this case, because we're starting with the wholes and we want to subtract off the parts. So I already have the whole segments right here. So if you look, I have AC is congruent to DB. So now what I have to do is I have to show that the parts are congruent, or the part I'm subtracting off is congruent, which is BC. So now I'm going to say that BC is congruent to BC, and that's by the reflexive property, because it's a shared side. And now we go into that segment subtraction proof, which is what we just did yesterday. So we had 5 steps. Now remember, the first 2 steps are you start with the congruent whole segments, which I have. Then step 2 is the reflexive property. Step 3 is you're going to subtract these. So I subtract those, and I end up with AC minus BC is congruent to DB. minus BC. So you started with something that's equal, the whole segments, you subtract off the same thing from both, and you still have something that's equal. So this is the subtraction property of equality. And then from there, so now I'm on step 4 of that mini proof. So I'm thinking about what I did yesterday and I'm doing step 4. So I have to state, well, what does this actually equal? So AC minus BC. So let me just bounce back up to the diagram. So if I have AC and I subtract off BC, I'm left with AB. And then if I take this, DB minus BC, so I'm going to bounce back up to the diagram for a second. So if I take DB and I subtract off this purple piece, I'm going to be left with the green piece, which is going to be DC. And the reason for this is the segment subtraction postulate. And then from there, now that I have some similarities here, now I have this piece, which is the same as right here. I can take and I can plug AB in for that. So I can plug in AB into step 7 there. And I can do the same thing for this. Since these are equal, I can replace DB minus BC with DC. And the reason for that is substitution. So now that actually gives me my third set of congruent parts. So that gives me my S, because that allows me to go up here and mark these sides as congruent. The green sides are now congruent. You can't just use these original red sides that I have marked because those are the whole sides. They're not sides of the triangle. So if you're trying to prove that the two triangles are congruent, you have to make sure that you're proving the sides of the triangle and only those sides, not the entire pieces. So that's why you have to go through that whole long process there. So here is the entire proof where you have side angle side being used. So now I can actually state that the two triangles are congruent. So triangle ABF is congruent. So step 10, triangle ABF is congruent to triangle DCE by side angle side. So when we're looking at that, we use that mini proof from yesterday, that 5-step mini proof, as just one way to get a set of sides, or it was the way to get the set of sides. So you should have those 5 steps from yesterday. If you look, I had the first step was the whole segments, then we had the reflexive property, so this was number 1, number 2, 3, 4, and 5 are different pieces that make up that mini proof, but they're now inside of a larger proof. So let's just do one more of these. So if you go to the next page, let's set up this next proof. So on the next page, we have some information. So let's write those givens down. We'll mark it. So you want to write your T here, statements, reasons. So for these, all of these givens are much different, so I'm going to list them all separately. So MS is the perpendicular bisector of LP. RM is congruent to QM. And we have angle A is congruent to angle B. So 1, 2, and 3 are all given. And now we go to mark our diagram. So the first thing I look at is my first given, which is MS is the perpendicular bisector of LP. So MS, right here, is the perpendicular bisector of this segment. So it's bisecting this segment as well as being perpendicular. So right away, that's giving me two conclusions I can make. I can say that I have right angles, and I can also say that these two segments must be equal to each other. So let me go ahead and write that down before we forget about it. So we have segment LM is congruent to PM, and that's because a perpendicular bisector implies two congruent segments. So you're splitting a segment into two equal parts. And then the other thing I know here is that I have two right angles. Now, I need to use three letters for these, so just make sure that you use your three letters. So I have, for this, I have angle SML and angle SMP are right angles. Don't use numbers for those because they contain multiple angles. So you have to make sure that you're using three letters to name those. So the reason for that is because a perpendicular bisector, very similar to perpendicular lines, perpendicular bisector implies right angles, or perpendicular bisectors and form right angles, something along those lines. And then the next thing I have to think about, again, is what should I do with those right angles? And if you look, in this case, these right angles don't make up right triangles. These are right angles that don't belong to triangles. So right away, that tells me that I need to say that these are congruent. That's the way that I want to go with this, because I don't want to say that they form right triangles because there's no triangle that has this as a right angle. So I'm going to go ahead and I'm going to actually say right now that those are congruent. So SML is congruent to SMP, and that's because all right angles are congruent. So then from there, let's look at what else we were given. We were given RM, and we were given QM. So that's going to be a set of sides. And we were given A and B are congruent. So when I look at this, I see right away that I'm going to be able to prove that these two angles right here are congruent to each other. And the reason why I know that is because if I have a 90-degree angle and I subtract off the same thing from both sides, what I'm left with must be congruent. So what I need to be able to do is I need to be able to prove that angle 1 and 2 are congruent to each other. Keep in mind, angles 1 and 2 are not vertical angles. Vertical angles would look like this. 2 intersecting lines. This is actually 3 intersecting lines. 1, 2, 3 intersecting lines to get 1 and 2. So you have like a V shape, not an X. So they're not vertical angles. So you do have to do our angle subtraction is what you're going to have to do, because you're given the whole angle, 90 degrees, 90 degrees. You're given these two parts are equal, so you can subtract off the two equal parts from the 90-degree angles, and you'll be left with two other angles that are congruent. The method that I'm going to be able to use then will be side, angle, side. So I need to make sure that my proof contains all of those pieces. Right now in my proof, I have this set of sides right here, RM and QM. I have LM, and I have this. I need to get the A. And if you look, I do have angle A and angle B are congruent, and I have angle SML and SMP are congruent, but I actually need to prove that angles 1 and 2 are congruent, because 1 and 2 are the angles that belong to these triangles that I'm trying to prove are congruent. So what we're going to do is we're going to subtract. And when you subtract, you're going to take the whole angles, which are these, and you're going to subtract off A and B. So that's going to be our first step. We're going to take these and we're going to subtract them. So step 7 will be SML minus angle A is congruent to SMP minus angle B. Now notice this time we didn't use reflexive property. So you don't always have to use reflexive property. You just have to make sure that what you're subtracting off is the same thing. So since A and B are congruent, that means they're the same, so I'm subtracting off the same thing. So I'm starting with something that's equal, and I'm subtracting off the same thing. So this is still going to be the subtraction property of equality. Starting with the whole angles and subtracting off two parts to keep it congruent. Then from there, we're going to look at, well, what does this actually equal? So what does it equal when I take angle SML and subtract off angle A? And then what does it equal when I take angle SMP and subtract off angle B? So let me go up to the diagram. So when I take SML and I subtract off angle A, I'm left with angle 1. When I take the other angle and subtract off angle B, I'm left with angle 2. So this is going to be equal to angle 1. This is equal to angle 2. Reason for that is your angle subtraction postulate. And then from there, well, look at the similarities. So I have this right here. So I can replace angle 1 with, or I can plug angle 1 into SML minus angle A. So angle 1 is congruent to taking this, and instead of SMP minus angle B, I can replace it with angle 2. And that's by substitution. So now this gets me my last piece of information I need. So now I can go up here and I can check off the angle, and I have proven side angle side because now I have the angles included between the two sides. So now I can say that the two triangles are congruent, RLM and QPM. So triangle RLM is congruent to triangle QPM. And that's going to be side angle side. So that concludes that proof. And again, a 5-step mini proof within this other proof. The mini proof is required for this angle addition or angle subtraction postulate so that you can prove that those parts are congruent, because they give you the other pieces that you don't need. You need the angles inside of the triangles. So that's why you have to go through the whole process. All right, well, that's it for today. Your homework will be a worksheet using, you have 2 proofs using these. So do your best with it. Use your notes to try to help you. Remember, use those mini proofs for angle addition, subtraction, segment addition, subtraction, and try your best on it. Have a great day.